All right, for 5.1, we're in chapter 5 now. 5.1, it's called the properties of parallelograms. So the first thing we have to do is talk about what a parallelogram is. Definition. The definition of a parallelogram is a quadrilateral. What's quadrilateral mean, you guys? So a figure that has four sides. Quadrilateral means a figure that has four sides in which both pairs of opposite sides are parallel. So let me give you a rough drawing of a parallelogram. This right here is a parallelogram. Okay? What makes that a parallelogram?
They're all parallel.
Well, first of all, how many sides does it have?
Four.
First of all, that's a quadrilateral, and I have both pairs. So I have this pair and that pair. These sides, right? Both pairs of opposite sides are guaranteed to be parallel. So my green and my blue are parallel. So the question I have for you then is this, okay? If I give you this picture, is this a parallelogram? No, because first of all, it doesn't have four sides, and it doesn't have two pairs of opposite sides parallel. What about this picture here? What if I gave you this one, this one, this one, this one, this one, and this one?
Nope.
Those are parallel.
Polygon.
Those are parallel. And these are parallel. It's not a quadrilateral. Very good. So therefore the answer would be no. So it has to be, we're talking about a four-sided figure in which both pairs of opposite sides are parallel. Alright, so it'd be nice, since we're going to be talking about parallelograms, if we could shorthand them so that we know what we're talking about. There's a symbol for it. So is this a parallelogram, A, B, C, D? Yeah. It sure is, right? Because I have two pairs of opposite sides that are parallel, and it's a four-sided figure. So the way that we draw parallelogram, we just draw this little figure right here, and we say parallelogram A, B, C, D. So that shape right there means parallelogram. Okay, there are three theorems that come along with parallelograms. Okay, the first theorem is this: if you have a parallelogram, then you're guaranteed that opposite sides of a parallelogram are congruent. Okay, so this is a theorem, so we're going to write it out. And it's going to say this: if a quadrilateral is a parallelogram, then both pair of opposite sides are congruent. So there's the picture that goes along with it, right? I have this side is parallel to this side, so that means that they're also congruent. I have this side parallel to that side, so that means they're also congruent. That's our first theorem. Opposite sides of a parallelogram are congruent. So the way that we abbreviate it in the proof for us is going to be this: if parallelogram, then opposite sides are congruent. So that is how we say it in the proof. Second theorem says this: so if a quadrilateral is a parallelogram, then we also know that opposite angles have to be congruent. So what that means is that this angle and that angle are going to be congruent, and this angle and this angle are going to be congruent. So it is a theorem, so it's an if-then statement, so that it goes like this: if a quadrilateral is a parallelogram, then both pairs of opposite angles are congruent. So how do we label this in the proof? The way that we say it in the proof is this: if parallelogram, then opposite angles congruent. That's how we say it in the proof. Okay, here we go. Last and final one. So last property of a parallelogram, okay? The diagonals, and the diagonals of course go from opposite vertices to opposite vertices, okay? The diagonals will bisect each other. Now the word bisect means they will cut exactly in half, okay? So the theorem for this one, the third final property says this: if a quadrilateral is a parallelogram, then the diagonals will bisect each other. So meaning that if it's a parallelogram, this line and that line will be, that line segment, those will be equal. That line segment and that line segment will be equal. The diagonals will bisect each other. So how do we, where'd it go? How do we say it in a proof? We say this. We say if parallelogram, then diagonals bisect. Whoops. Each other.